हेलो स्टूडेंट्स, वेलकम टू दिस चैनल। इस वीडियो में हम एंगुलर मोमेंटम ऑफ ए पार्टिकल और टॉर्क के 4 इम्पॉर्टेंट केसेस डिस्कस करेंगे जो कि डिफरेंट इंजीनियरिंग एंट्रेंस एग्जाम्स में पूछे जाते हैं। हम ये देखेंगे कि एंगुलर मोमेंटम और टॉर्क रेफरेंस पॉइंट पर डिपेंड करते हैं, और ये भी देखेंगे कि wxMaxima कंप्यूटर अलजेब्रा सॉफ्टवेयर को यूज़ करके कैसे हम वेक्टर कंपोनेंट्स लिखते हैं और क्रॉस प्रोडक्ट ऑफ 2 वेक्टर्स निकालते हैं। एंगुलर मोमेंटम और टॉर्क की प्रॉब्लम सॉल्व करने के लिए एक्स वाई जेड एक्सिस का सेटअप करना आवश्यक है। अगर एक्स वाई एक्सिस दी गई हैं तो जेड एक्सिस निकालने के लिए हम राइट हैंड स्क्रू का यूज़ करते हैं, रोटेशन स्क्रू का यूज़ करते हैं। सपोज इन दिस केस हियर दिस इज एक्स एक्सिस, this is y axis. So if you rotate a screw from x to y, direction of motion of tip of the screw is along this direction. So this is z. So x y z axis यहाँ सेटअप हो गई। दूसरा एग्जाम्पल हम लेते हैं। सपोज here x is here, y is in this direction. If you rotate a screw from x to y, tip of the screw moves in this direction. So this is the z axis perpendicular to x and y both. So this is how, using a screw motion, this is how we decide the direction of z axis. Now we come to the problem. Angular momentum of a particle को डिफाइन करते हैं with reference to certain reference point L is equal to R cross product of P. R is the position vector of the particle with that reference point. P is the momentum of the particle. This is the angular momentum with reference to point is equal to R cross P. So R is given as X. Suppose R vector is in a plane. So R is given X I plus Y J, momentum Px plus Py J. Suppose there is no Z component here. Position vector and momentum vector are written here. These vectors in written here I J K form, I plus J. In computer algebra software systems wxMaxima vector components को स्क्वायर ब्रैकेट में लिखते हैं. So this R is written as X, Y, this magnitude here, this magnitude here. There is no Z component, स्क्वायर ब्रैकेट में 0. एलिमेंट्स जो हैं कंपोनेंट्स कॉमा से सेपरेट कर दिए जाते हैं. मोमेंटम P is written as Px here, Py, comma 0, square bracket close. This is how in computer algebra software vector components are written, and this is the components in IJK form. Now we consider case 1. Now R and P, they are in XY plane, so obviously the angular momentum Z will be along Z axis. Now case 1, suppose a particle is moving along x axis with a constant velocity. Constant velocity means the direction of the velocity and magnitude of velocity is constant along this direction. So we have to calculate the angular momentum of this particle at this point with reference to O and with reference to B. So if we write angular momentum about O, about origin, so that comes out to be 0 because R and P both are parallel. So R cross P is equal to 0. Now what about the angular momentum about B? If we have this B point here, so angular momentum R, this is R vector, cross P, R cross P. So R will have 2 components. Suppose this B is at a distance S, along S, and this is X. So perpendicular distance multiplied by the velocity. So in this case, momentum about B will be equal to M into S, the distance, into velocity vector into K. Position vector of the particle B is equal to minus Sj plus Xi, velocity vector of the particle Vi. And if we cross multiply these two, So j cross I will be minus k. So this becomes msvk. So direction of the angular momentum about B is along positive z axis. So here we see the angular momentum changes with choice of reference point. With respect to this point, angular momentum is 0. With respect to this point, angular momentum of this particle moving along this direction is changed msv along z direction. इसको एंगुलर मोमेंटम निकालने का दूसरा तरीका होता है कि उसको डिटर्मिनेंट फॉर्म में लिख दिया जाए मैट्रिक्स के एस्टिमेशन में. सो L इज इक्वल टू m I j k x r components and velocity components. x y is equal to m x minus s 0 velocity x. There is motion along x axis, vy 0, by 0, vz 0. So if you solve this determinant, the angular momentum msv along k direction. In maxima notation, r is equal to x component minus s comma 0 velocity v comma 0 comma 0. So if you cross product अगर हम इसका करेंगे तो L जो है इस तरह के फॉर्म में आ जाएगा 0 comma 0 msv. मैक्सिमा में क्रॉस प्रोडक्ट कमांड्स लिखने का तरीका होता है कि एक वेक्टर पैकेज को लोड करते हैं, r को हम डिफाइन कर देते हैं स्क्वायर ब्रैकेट में x कॉमा माइनस s कॉमा 0 हियर वेलोसिटी कोलन v कॉमा 0 कॉमा 0. So angular momentum m cross r cross v is defined as r tilde. Tilde is a notation. R cross v express to displace this cross product. So if we execute this command in wxMaxima, we get the output in this form 0 comma 0. So there is element of the angular momentum along z direction. Magnitude is msv. So magnitude is constant along z direction. So if it is constant, so if we take the derivative of this constant, so torque is 0. So in this particular case, for a fixed origin, there is no change of angular momentum, that is L is constant and torque is 0. Now we consider the second case. In this case, particle is moving along x direction, but there is a retarding force in opposite direction here. So what about the angular momentum at this point B? In this particular case, the angular momentum is same as earlier, msv along k, because we can find out r cross v. So this is the perpendicular distance multiplied by this velocity. So r cross v msv along k direction. But the velocity here is not constant, it depends with time. It decreases in magnitude with time. So direction is positive z axis, but the velocity magnitude is decreasing. So for the torque, if we differentiate this value, this comes out to be negative because the velocity decreases here, or we can say the force is in the minus k direction, force is minus x direction, minus x direction. So the torque is minus sf k direction. So torque is along minus k direction and angular momentum is k axis. So here you can see torque is along this direction and angular momentum is along this direction. Remember, this torque is along the direction of delta L, not about L. Delta L is the change of the angular momentum. The change of the angular momentum is decreasing, so this is along this direction. Now third case is, suppose a particle free falling under gravity. In this case, particle is free falling under gravity here under the force F is equal to mg with reference to this origin O, which is at a distance s from this point A. So r cross v. So r cross v momentum is equal to velocity v is equal to at time t is equal to g into t, u is equal to 0. So mg st. It is along k direction, as you can see, r cross v. On tau is equal to r cross f. tau is equal to r cross f. F is equal to this direction, f is equal to this. So r cross f is equal to mgs k. Or you can differentiate dl by dt. So this is mgs again here. So here you can see the velocity increasing with time. In this case, velocity was decreasing with time up in the opposite direction. So in this case, the torque and angular momentum both are in the same direction k. Case 4 is angular momentum of a particle. If a particle moves in a circle with a constant speed, the magnitude, so in this particular case, in a circular motion, the velocity is always tangential. So r cross v is, r is fixed, v का magnitude भी fix होता है, and they are perpendicular to each other. So angular momentum r cross v is always mvr, and this direction is perpendicular to the plane of circle. So in this particular case, angular momentum, you can see mvr, it is a constant in magnitude and direction is also fixed. So angular momentum is a constant vector. So if we differentiate it, torque is 0. So in circular motion, angular momentum with respect to center is conserved, but the linear momentum as velocity v varies at each point is not conserved. That is all for this video. Thank you.